Okay, so I'm back. There was some internet issues. My Google Chrome has crashed. So let's start the section now. So today the section is about the 14 problem in Project Euler. So let's see this question. Hmm, oh yes. So um, I want to say sorry to you also that we have not been recording the video for 2 weeks. So That's our that's due to our real world jobs. So we are so busy. So luckily I managed to squeeze out some time. So let's see this question. Mm, okay, Champernowne's constant. An irrational decimal fractions is created by concatenating the positive integers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. It can be seen that the 12 digits of the fractional parts is 1. So if dn represents the n digits of the fractional part, find the value of the following expression: d1, d10, d100, d1000, d10,000, d100,000, 1,000,000. So what we are going to do is a bit different with the numbers here. I'm going to use decimal for it. So instead, I just use a normal integer. Okay, so let's see the code. So this is the length for the integer. So we just need to um, get the length as the question wants. So we don't have to construct a double just for the sake of solving this question. Okay, so next checkpoints. So this is the position that we want to check, and next checkpoint, this is distance for the array. So if we after getting the first number, then okay, next if we become 1, then we'll search for the tens number, and next we'll search for the hundreds number. So this checkpoint will points to the array index in checkpoints that we want to check for the numbers. So integer answer equals to 1. This is because the answer once times. So if we put 0, then our result will get 0. So if we put 1, then okay, so the result will be fine. So next, first we get here, we check for the length. In fact, this is for checking the numbers. We start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until this number, and we add I plus plus, so we keep on adding number. So this is current length. Current length is for adding the length for the number. Let's say we have 2, then the log 10 will show 0. So to correct this problem, that we add 1. So for 100, log 10 would be 2. In fact, for the range from 0 to 99, no, 0, not 0 to 99, 0 to 9, then the value will return 0 for log 10. For 10 to 99, the value would return 2. No, 1. Okay. So basically, log 10 table, how I call it. From 0 to, sorry, log 10 0 is undefined. So 1 to 9, you get 0. 10 to 99, you get 1. And 100 to 999, you get 2. So it serves a good purpose for us to get the number of digits in a certain number. So for this, but it lacks 1 for the actual number of digits that we want, so we should add 1 for it to correct it. So it will be like this. So yeah, this how I get the number of digits. So after getting the number digits for I, right, I add it to a current length. I simulate the concatenating action. So if our current checkpoint, after I added the number, our current checkpoint is more, our current length is more than the checkpoint that we want, which means that the number is situated somewhere inside the I that we want. So this is the perhaps for 10 we will get here. For 10, this is 1, 2, 3, 4, 5, 6, 9, 10 is here. So our current, and here we will stop here. So the current length is 11. So okay, so our checkpoint is 10. Okay, so okay, current length is more than checkpoint. That means the checkpoint is somewhere at the number here. So last position, that means what, how many numbers that we want to truncate to get the numbers that we want. So next, to divide. So after getting that, we know the numbers that we find is lying somewhere inside 10. So to divide equals to 10. So now the last position is 1. Because we want to truncate one number only. If for 100, then you do the same thing. For every checkpoint, you do the same thing. So last position is 1, so we truncate 1 by dividing it. So 10 divided by 10 is 1. So that's it. We truncated it. And the number that we want to find should be here, 1. But for some cases, if you go to like 1,000 or 10,000 or something, then you might face an issue like this. So to cater this problem, perhaps should be, yeah. Yeah, perhaps you could get something like this. So to cater this issue, I use remainder when multiplying the numbers that we want by using the remainder of 10 to that value. So if you want 7, then okay, we use a 4,567 remainder of 10, so we'll get 7. So this is the numbers that we want. So okay, so after getting that, okay, so now we got the checkpoint. We have reached the checkpoint, so we'll add next checkpoint. So maybe for as for 10, our next checkpoint is 100, and next 1,000, and until the end. So perhaps I could modify here a bit. Next checkpoint equals to checkpoint is not like less than. Substitute purpose. So yeah, there's some performance difference. So let's see. Okay, negligible. So let's. Oops. Okay. So now we have reached our final checkpoint. That's the condition. Okay, this is pretty simple for this question. You just have to think for another perspective. So okay, after that we print answer. So this is pretty fun. I'm pretty satisfied with this solution, which only takes 11 milliseconds. So yes, that's all about this question. In fact, you can customize this question. So you can get the solution from GitHub because I have just updated my GitHub. It had not been updated for a long time. So yeah, for the sake of allowing you to get the source code from the video that was uploaded previously. Okay, so you can get them now. So happy programming. So see you. Goodbye.